In this video, we're going to discuss going between rectangular and polar coordinates and do a couple of quick examples. So first off, we have some point up here, xy, and we normally are given a horizontal and vertical distance from the origin. So our horizontal distance would be here, our vertical distance would be here, and that's how we would define this point. Now with polar coordinates, what we're going to do is we are going to go directly from the origin to the point, and we're going to get a measurement of the angle made between that line that goes directly from the origin and the point and our horizontal x-axis. So we'll call this angle theta, and this line we'll call r. Okay, we like r because we think of it as a radius of a circle. Now, we know from rectangular coordinates that this would normally be x, and this would normally be y. That would give us our horizontal and vertical distance. Well, let's see how we would figure these out in terms of r and theta. Well, notice what we have here. We have a right triangle, and if this here is x, this distance here is also x. So to get r, well, I've got the Pythagorean theorem between these three sides. So I know that r squared equals, a little high, r squared equals x squared plus y squared. And if we solve that for r, we would take the square root of both sides. So r is square root of x squared plus y squared. So that's how we would find the r, or the radius. Notice we have our equation of a circle centered at 0, 0 with a radius of r. The other conversions we need are for getting x and y between our polar and our rectangular. Now notice what x is. Let's look down here because it might be a little easier to see. It's the adjacent side of my triangle. I have theta, and I know r is the hypotenuse. So if we recall our trig functions, cosine of theta equals the adjacent side, which in this case is x, over the hypotenuse, which is r. So what that tells me is, solving that for x equals r cosine theta. So r cosine theta. Finally, y is going to be very similar, except it's the opposite side, so I'm not going to go through the derivation, but y would be found by r sine theta. This should look really familiar because we know from trigonometry that r cosine theta, r sine theta gives us a circle of radius r if we go from 0 to 2 pi. Last thing is theta. How would we find that? Well, remember, the idea is we're given something in rectangular and we want to go to polar. So we're given x and y and we want to get theta. So we know that if x is the adjacent side, y is the opposite side. We know that tangent of theta is opposite over adjacent equals y over x. So that's going to be the relationship between theta and y over x, and we'll solve that for theta by using our inverse tangent, or arctan. And so a lot of times you'll see this written as arctan of y over x. Now, this is great for in the first quadrant, but we're going to have to adjust that depending on what quadrant we're in. So in general, there are our conversions, and we have to be careful about which quadrant we are in. Now what I'd like to do is do a couple of examples using my formulas here, so you can kind of see how this plays out. So I'm going to put this right here. Oops. And let's say we want to find the rectangular coordinates given that the polar coordinates are 5, pi over 6. This is nice because it's very straightforward, because we know that in rectangular x is equal to r cosine of theta. Well, polar coordinate is always given r comma theta. So I really have a very straightforward conversion. It's 5 cosine of theta. Excuse me, well, we know theta. Let's rewrite that. It's 5 cosine of pi over 6. And we know the exact value of cosine of pi over 6, which is rad 3 over 2. So this is 5 rad 3 over 2. Y is going to be very similar because y is just r sine of theta. So 5 sine of theta, I did it again, 5 sine of pi over 6, excuse me. Sine of pi over 6 is a half, so the y-coordinate is 5 halves. So the equivalent rectangular point is 5 rad 3 over 2, 5 halves. Makes sense that the x is a little larger because if you notice what we have a 30-degree angle. If you can imagine how that's plotted, it's going to be on here, sitting on a circle of radius 5. So the x-coordinate will be larger than the y-coordinate. Always want to check and make sure our answers make sense. Now how about going the other direction? So let's say we want to find the polar coordinates given that our rectangular is 4, negative 5. Easiest thing to do first is find r, because it's simply from our Pythagorean identity. R equals the square root of 4 squared plus negative 5 squared. Do you need the negative in there? No, absolutely not. It's going to get squared anyways. 4 squared is 16. 5 squared is 25. So we have the square root of 41 is our r. If you want that as a decimal, you can. It might be a little easier if you're trying to plot it, but I'm just going to leave it as square root of 41. The other thing we need is theta. Now, according to this says theta is arctan of y over x. Now, depending on what quadrant you're in, that may or may not work out for you. So let's just see what happens when we do arctan of y over x, and I'm going to do it in radians. We can always convert. Y is negative 5 over 4. And I'm going to bring my calculator in here. And I'm going to do arctan of negative 5/4. And I get negative 0.8961. I'll go to 4 decimal points. A couple things that I want to mention here. Number one, that will actually work. Here's why. The point for negative 5 is in the fourth quadrant, as is this angle measure. Now that being said, we might want to measure our angle from the positive x-axis. So what I can do is I can take my measurement and add 2 pi. That would give me to 4 decimal places the angle measurement all the way from the positive x-axis. So one way of writing this might be rad 41, 5.3872. Let's say we have a concern about dealing with rounded off numbers. Another way we could have handled this is square root of 41, 2 pi, and what we'll do a lot of times is just use this as a reference angle. We know we're in the fourth quadrant, so instead of doing arctan of negative 5/4, I might just go ahead and do arctan of a positive 5/4 because I know that gives me the reference angle, and all I have to do is subtract that from 2 pi. Now, one last thing I want to point out before I end this video. This would have worked. If I would have put rad 41 negative 0.8961, that would have worked out perfectly because we were in the fourth quadrant. But something to notice, had my coordinates been negative 4, 5, so this is just an example here, think of this as scratch, this would have been the same, and this would have been the exact same, but I'm no longer in the fourth quadrant, I'm in the second quadrant. So if we had done that, we'd have to account for that by saying, okay, well, square root of 41 is still my r, but now when we're doing our theta, we will need to be in the second quadrant, so it's going to be just pi minus the arctan of 5/4. So that's why you need to be careful about what quadrant you're in when you're going from rectangular to polar, and it's always a little better to deal with reference angles because that will force us to pay attention to the quadrant we need to be in.